Hello everybody. In today's video I'm going to talk about exponents. They are used to represent numbers. Often people use them to write very large numbers like the distance from here to the sun. They can also be used to represent very small numbers like the length of an atom or like the radius of an atom or something like that. I could write the number 32 as a product of factors. So I could say the number 32, that is the same as 2 times 2 times 2 times 2, 2, 4, 8, 16 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. So these all could multiply together to equal 32. We can also use exponents to show this. I could say 2 to the 5th power. 2 to the 5th power. And what that means is use 2 as a factor and multiply it 5 times. So 1, 2, 3, 4, and 5. So I just did 2 times 2 times 2 times 2 times 2. When I write 2 to the 5th power, the 2 is called the base, and the 5 is called the exponent. Okay? This can also be called the power, right? Like when I say 2 to the 5th power. So we can use exponents to write the product of a bunch of same factors. So if I write 3 times 3 times 3 times 3, instead of that I can write 3 to the 4th. If I write 2.683 times 2.683, I could just write that as 2.683 to the 2nd power. Now some powers have special names. For instance, if I write 4 to the 2nd power, that's also, let me show the two different names. That's 4 to the 2nd power. Now any exponent and base can be written this way. Put the base there and the power there, or the exponent there. But when a 2 also means squared, so I could say 4 squared. If I wrote 5 to the 3rd power, I could say 5 to the 3rd power, or I could say 5 cubed. Okay, so this would be 4 squared, and this would be 5 cubed. And once we get past 3, you just say to the 4th power, to the 5th power, to the 6th power, to the 100th power, to the millionth power, whatever. But for 2 and 3 we use squared and cubed. Alright, so let's do some examples here. So if I asked you what is 3 to the 4th power, you would say, or if I said what is the value of 3 to the 4th power, you would say, well, that's 3 times 3 times 3 times 3. You could do this in a couple different ways. You could say, well, that's 9 times 3 times 3, and that would be 27 times 3, and that would be 81. A lot of people don't know that 27 times 3 is 81, though. So another way you can do this, because remember, with multiplication, you can do it in any order you want. You could say 9 and 9, and that's 81. That might be an easier way to do it. So with exponents, we actually have to figure out where that goes in the order of operations. So if I had this problem, 2 to the 3rd power minus 6 divided by 3, the order of operations is grouping symbols, exponents, multiplication, division, or division multiplication. That's left to right. Same thing with addition, subtraction, right? So here, there's no grouping symbols, so we need to do exponents first. The exponent only sees what is directly below it and to the left there. So this exponent doesn't see any of this stuff over here. It just sees that 2. And it says, hey, I need to multiply, 2 needs to be multiplied 3 times. So 2 times 2 times 2. So we would do that. 2 times 2 times 2 is 8. And then I'm just going to write the rest of it so we can figure out what to do next. So I've done exponents. Now we have subtraction, division. Division comes first, so 6 divided by 3 is 2, so we have the 8, the minus, and then this was 2. And then obviously 8 minus 2 is 6. Let's try another. If I have 5 plus parentheses 2 plus 1 parentheses 2. Well, again, the order is grouping symbols go first, so we have to do that first. So the grouping symbol here is 2 plus 1, so that's going to be 3. And then the 2 is still hanging out there. It's kind of out here, out of the parentheses. Now the 2 is going to look down. It's going to see, hey, there's a parentheses in there. So whatever's in the parentheses, I'm going to square that. So 3 squared is 9. So now we have 5 plus 9. And then 9 plus 5 is 14. So that's kind of how we work it in with the order of operations. When we get into negative numbers and multiplying negative numbers or having a negative number to a power, that can get a little more confusing, and I'll talk more about it at that time. There's actually a time where you can have negative exponents, which also can be confusing, but again, I'll do more examples and we'll talk more about that. If you're interested, you could try to look it up early if you want as well. Let me get rid of this. Okay. So let's try one more example, then I'll end the video. So let's say we had something like 10 minus 8 to the 4th power times 3.5. So here, again, we have to do the grouping symbols first. So 10 minus 8 would be 2. And then I'm just going to write the rest out. Now we have an exponent and we have multiplication. Exponent has to go first, so this means 2 to the 4th power. So the base gets multiplied 4 times, so 2 times 2 times 2 times 2. We could actually write it out if we want. Some people, since it's just multiplying by 2, would like to do that in their head. So 2 times 2 is 4, times 2 is 8, times 2 is 16, times 3.5. You could try that in your head if you wanted. 16 times 3 is 48. Half of 16 is 8, so 56 should be the answer. But to be confident, we should do this over here. So 6 times 5 is 30. And then we have 5 times 1 plus 3. Placeholder 0. Another 8. With a, that's gone now. So 1, and then 3 times 1 is 3, plus 1 is 4. So we have 0, 6, 1, so 56 because 1 digit after the decimal. So 56 is our answer. That is all for the video. Don't forget to answer the form below.